Evaluate the integral square root of a squared minus x squared dx. Recall that when we were differentiating x and x, we got 1 over square root of x squared minus 1. So you see that this thing has something in common. So you can put your x to be equal to a sine theta. Then having done this, you can make theta the subject and you have arc sine x divided by a. So let's call this one equation asterisk and call this one equation asterisk. So differentiating equation asterisk gives us the x is equal to a cos theta d theta. So call this one asterisk. So now let's go back to initial integral and substitute all these values there. So we have the integral of square root of a squared minus x squared dx is equal to the integral of square root of a squared. Then my x is a sine theta. So x squared will give me a squared sine squared theta. And the x is equal to a cos theta d theta. So I have that. So I can now say that my integral of square root of let me factorize a squared out. So I have a squared into bracket 1 minus sine squared theta, then multiply by a cos theta d theta. So according to trigonometry identity, if I have 1 minus sine squared theta, is the same thing as cos squared theta. Because if I have sine squared theta plus cos squared theta is equal to 1. So from here, I got the first equation. Cos theta is the same thing as square root of 1 minus sine squared theta. So anyway, I see square root of 1 minus sine squared theta, I'm going to put cos theta there. So I have the integral of a, then 1 cos theta multiplied by a cos theta d theta. So if I multiply everything here now, I have a squared, then cos squared theta d theta. Recall that cos squared theta is equal to cos 2 theta plus 1 divided by 2. So if we want to get this one, how I got this, we have to understand the trigonometric identities very well. So from here, I can now say the integral a squared cos squared theta d theta is equal to, let me take this constant out, then the integral, wherever I say cos squared theta, I'm going to put cos 2 theta plus 1 over 2, then d theta there. Here, I can now say a squared. So let me take this 1 over 2. Let me write it here beside it. So if I integrate cos 2 theta, I have 1 over 2 sine 2 theta. Then I have 1 over 2 here also. So I'll say that plus 1 over 2 theta plus c. So is equal to a squared into bracket 1 over 4 sine 2 theta plus 1 over 2 theta plus c. So they have 1 over 2 in common, so I can take it out, I have a squared over 2 into bracket sine 2 theta over 2 plus theta, then plus C. So from here, I can see that I have sine 2 theta, which is the same thing as 2 sine theta cos theta. So I can substitute it inside. So I have a squared over 2 into bracket 2 sine theta cos theta plus theta, then everything plus C. And don't forget these two. So these two cancel these two. So I have a squared over 2 into bracket sine theta cos theta plus theta, then plus C. I can expand and have a squared over 2 sine theta cos theta plus a squared theta over 2, then plus C. So from here, I need to write value for sine theta and cos theta. So I can draw a triangle, right angle triangle, and call this side A, call this side X. So here is the theta. If you look at this one, this will be my opposite, and this will be my hypotenuse, and this will be my adjacent. So I can answer that according to SOHCAHTOA. So sine theta will be equal to opposite over hypotenuse, which is x over a. We need to find adjacent. So we need to find adjacent. So according to Pythagoras theorem, I'll have a squared, which is hypotenuse, is equal to x squared plus adjacent squared. So we want to make adjacent squared the subject of the formula now. So I have adjacent squared is equal to a squared minus x squared. So adjacent will be equal to square root of a squared minus x squared. So here will be my square root of a squared minus x squared. So now to find cos theta. Cos theta will be adjacent divided by hypotenuse, which is equal to square root of a squared minus x squared divided by a. That means anywhere I see sin theta inside this equation, I'm going to put x over a, and anywhere I say cos theta, I'm going to put square root of a squared minus x squared divided by a. So I have a squared over 2, then x over a multiplied by square root of a squared minus x squared divided by a plus a squared theta over 2 plus c. A cancel one a out, another a cancel a out. So I have x over 2, then multiply by square root over a squared minus x squared, then plus a squared over 2 theta plus c. And recall that my theta is equal to arc sine x over a. So I have to put it inside this equation. So I have x square root of a squared, x squared minus x squared over 2 plus a squared over 2, then arc sine x over a, arc sine x over a plus c. So this is the integral of square root of x squared minus a squared is equal to x over 2 square root of a squared minus x squared, so plus a squared over 2 arc sine x over a, then plus c. So we have square root of difference of two squares. This is the formula that we are going to use. So that is that for today. Till I see you in the next class. Thank you. Bye bye.